Hello and welcome back to our session on model security and IP protection. In an age where AI models are often the result of millions of dollars in research and development, safeguarding them from unauthorized use is crucial. Today's focus is on digital rights management, DRM for AI, how to control model usage and use watermarking techniques to prove ownership of both AI generated content and the underlying model parameters. By the end, you will see how DRM-like approaches and watermarking can help you defend your AI investments and track unauthorized use or duplication. Let's dive right in. So why DRM matters in AI? DRM or Digital Rights Management typically refers to technologies that protect digital media like music and movies from piracy. But it's becoming increasingly important in AI also because of high R&D costs. Developing advanced AI models can cost millions in compute resources, data acquisition, and engineering talent. Competitive advantage: a stolen or copied model could instantly catapult a competitor to your level without the development expenses. And unauthorized usage: if your AI solution is integrated into external products, how do you ensure users can't copy or modify the model for other purposes? According to Gartner, the worldwide business value derived from AI will reach $5 trillion in 2025, illustrating just how large these risks and rewards can be. In the AI context, DRM-like techniques mean implementing rules and technologies that restrict access. Only licensed or paying customers can query or use your model. Enforce usage policies. Define how many queries for which tasks and for what duration the model can be used. And monitor and audit. Continuously log model usage, detecting suspicious patterns like mass extraction attempts. Think of streaming services like Netflix. You pay a subscription, log in, and can watch content within certain usage limits. DRM for AI aims to provide a similar framework for your ML model. Here is a step-by-step approach to implementing DRM for your model. Starts with user authentication. Require an API key or OAuth token for each request to the model. Tie each key to a specific license or usage agreement. Number 2 is usage tracking and metering. Log query counts, the type of requests, and possibly the data size processed by the model. Trigger alerts if usage exceeds expected thresholds, a tactic that can match model extraction attempts. Number 3 is license enforcement. Similar to commercial software licenses, you define whether the model can be used for commercial versus research purposes, how many seats or applications it can power, and for how long. Now, if the client's usage period ends, their API access should be automatically revoked. Number 4 is local versus cloud hosting. Cloud-based hosting allows you to keep the model on your servers, restricting direct access to the weights. If distributing the model locally, consider partial encryption or hardware-bound solutions that prevent easy copying. A 2022 Microsoft study indicates that 79% of enterprise AI solutions are deployed via APIs or cloud services, highlighting the effectiveness of a server-controlled DRM approach. Next, let's talk about watermarking, embedding hidden identifiers in either AI-generated artifacts like images, text, or audio, and model parameters themselves. The benefits: proof of ownership. If someone claims your content or model is theirs, you can prove it's originally yours by revealing the hidden watermark. And deterrence. Knowing a watermark is there might discourage unscrupulous actors from stealing or misusing your outputs. Some digital artists already use transparent watermarks on images. For AI, we can do something more sophisticated: an imperceptible pattern only detectable via special methods. When your AI system produces output, say an image generated by a GAN, you can embed subtle patterns into pixel values. Now, this watermark is invisible to the naked eye but can be detected by a scanning tool. like spatial watermark, hide data in pixel intensity variations, or frequency domain watermark, alter certain frequency components of the image. For an example, a major stock image AI service might watermark outputs so that if someone tries to sell or claim them elsewhere, the watermark can be extracted to confirm original ownership. A tip would be make sure your watermarking method does not degrade the quality of the output. Some advanced methods maintain a less than 1% difference in pixel distribution. Now comes watermarking model parameters, neural network watermarks. It is trickier but equally powerful. You embed a secret pattern within the weights or activation patterns of the network. For instance, backdoor trigger. If you input a specific trigger pattern, like a certain image or string, the model yields a known response that only your watermarked model would produce. And parameter perturbation, slightly adjust a subset of weights to encode a binary or multi-bit signature. A use case for this could be if someone copies your model and claims it's theirs, you show the backdoor trigger in a demo. Your watermarked model will produce a unique output that the stolen model also exhibits, exposing the theft. Now, to put it all together, when you combine DRM-like approaches for usage control with watermarking, you get a robust solution. DRM ensures only legitimate paying customers or authorized users can access or query your model, and watermarking acts as a silent safety net. If an attacker somehow bypasses your DRM or copies outputs, you can still track and prove ownership. Outcome? A layered defense that keeps your intellectual property safe from unscrupulous actors and also provides legal evidence if you need to confront infringement. Let's walk through a quick example. Say a startup called GenArt offers a cloud-based service generating AI artwork. The DRM setup: users must log in with API keys. Rate limiting prevents more than 100 images per day per user, and usage logs records each request's time and ID. Then your watermark for outputs. GenArt hides an invisible pattern in every generated image. A proprietary scanning tool can detect this pattern, proving the image was produced by GenArt's AI. And the model parameter watermark. If someone obtains GenArt's model weights, there is a hidden backdoor trigger, a specific color matrix, causing the model to output GenArt protected in the bottom corner. If a competitor's stolen model does the same, it's clear they have used GenArt's original model. The result? This layered approach ensures GenArt can track usage, detect abnormal activities, and prove content ownership, deterring would-be thieves. So before we wrap up, here are the key takeaways. DRM for AI: restrict model usage with license-based controls, API authentication, and usage monitoring. Watermarking: embed hidden identifiers in your outputs or model parameters to prove ownership and data theft. And layered defense, combining both DRMs like controls and watermarking, ensures a robust security strategy, protecting your AI's economic and brand value. Remember, as AI's value grows, projected to reach $5 trillion in business value in 2025, it's critical you safeguard your IP from unauthorized use or duplication.